Welcome to this technical corner. Today we're going to be looking at the H Series from Takumi, supplied by CNC Technologies. Now, this 3-axis machine tool is a very high spec machine tool. Now, Paul, we're going to find out why. Tell me, in your opinion, why this is.
Well, this is what we do, isn't it? We look at these sorts of machines and sometimes you come across a range where it kind of excites you and you find out some of the reasons why they're so popular around the world. And certainly the H Series, when you start to drill into the detail of how these dual column machines are built and some of the things that they offer, they really do look like a challenger when it comes to somebody looking for something that's very heavy duty. As you can see here, I mean, the range starts from a small H6 dual column machine right the way up to something of this size, which, you know, you can interpret for whatever industry would suit a machine that big.
Now, you mentioned dual column, so let's touch upon that to start with. We'll move on to the foundation, but dual column, can you explain to our audience what benefits a dual column has?
Well, I mean, if you've got your normal sort of C-frame cantilever style machine, of course there's restrictions in maybe the potential you've got for a Y-axis, because by the time that, you know, the head or the spindle's at its extreme point, there's always going to be an area where even physics denotes that you're going to get some kind of droop, and you're not going to be able to machine in the same condition at those extreme points as you would if the machine or the machine is supported by a dual column. Now, essentially what a dual column means is, you can see here you've got a column at the back and a column at the side here, and then of course your spindle motion is going from left to right, which means wherever you are on this point of across the bridge, should we call it, it doesn't matter, because you've still got the same support for your spindle as you have, you know, at any corner point of this table. Your support is exactly the same, which means you've got stability and the opportunity to get that much bigger Y-axis.
That's another good point, a bigger Y-axis. What benefits would that have?
Often we go and we speak to engineers and they will buy a vertical machining centre based on the Y-axis and not the X. You know, they will say, actually, I must have 650 in the Y. You know, that is what I need. So therefore, I need to buy a meter machine with the X. Now, that's kind of nuts, really, because they might not need a meter in the X, but they must have a certain size Y-axis. And I think with the dual column style machine, you're unrestricted. You know, your X obviously can go much bigger, but you could have almost a square environment, which sometimes can be perfect for tool makers and die and mould manufacturers.
I can see the benefits of the rigidity benefits that you're getting with the double column in regards to or in comparison to a C-axis. But assuming we're cutting a very big component on that particular machine and you're hitting it at such a rate, what kind of designs are there within the machine to stop the actual spindle drooping?
Well, let's pull on to the next feature here on the screen, because this is very, very important, and there's a few areas that Takumi, we're getting into the real nitty gritty now, but you'll see on a machine like this, you've got where your spindle is moving backwards or left to right on the bridge, and here you'll notice you've got a guideway at the top and a guideway at the bottom. Now, on a lot of machines, what you'll have is these will be almost stacked on top of each other. So essentially, you've got one guideway there and one guideway in the same sort of how would you class it, but flatness as the top one. Whereas here you've got like the step ladder approach. So this guideway is actually positioned in front of this guideway. Now, what that means is as your X-axis is moving through or under the bridge, it means that the spindle is not going to suffer with any potential movement in that direction, which means you can hit the machining environment harder, but it also means the wear and tear of this entire area is far better than another style of design. So it's a way they use this step ladder.
So this is a USP from Takumi. So not only are you getting the rigidity in one axis, but you're getting it in the X-axis as well.
Yeah.
So both axes you're getting ultimate rigidity. Now, the rigidity runs throughout the machine tool. Tell us about the casting and the foundation.
Well, you can see here, and this is why it's great to be able to do these technical corners, because you can actually identify straight away here that you've got a one-piece casting on the bottom. You've got the linear rail motion, which is driving the X-axis. But you can see here, as you're building up the machine, you can see how the different parts of the machine are constructed. Now, ultimately you want to be able to have as much weight down at the bottom end of the machine as possible in order to, to play with gravity and of course eliminate vibration or anything that might affect your surface finishes. And the way this machine is constructed lends itself to all of those aspects.
You mentioned surface finishes. What kind of components lend itself to this kind of configuration?
Mould and die industry, but really across the board. I mean, I think most machine tool manufacturers these days don't want to pigeonhole their machines into an industry. They want to provide a machine that has plenty of options with it. So with these machines, you've always got the spindle face and taper spindles, but you can go for different variants in the spindle, higher speed spindles. Another interesting point, and I think if we move on to the next slide or the next video, you'll start to see the machine as it kind of as it is in a three-dimensional format. But one of the other areas I wanted to pick out on, we talk about the spindle. This particular machine, they focus very heavily here on this spindle area and keeping it separate from the rest of the casting. Now the reason they do that is because when you're machining, you're going to generate heat, and heat in any machining operation is the absolute enemy. You really don't want it, and you want to keep it as separate from the rest of the mechanics of the machine as possible and the casting, because any heat can cause growth, and any growth will affect precision, and any growth can affect everything on the machine. So here what they do is they kind of put a heat jacket around the spindle, and they keep all that away from the casting, so it keeps every area very, very cool.
I mean, that is very impressive, Paul. So this is all being done and designed to achieve ultimate accuracy. What kind of accuracy can this machine tool?
It's down to microns, and I think when you look at machine tools that are built, certainly in Asia, they generally tend to build them to the JIS standard of machine, which is a certification. It's what machine tools require. But with these, they manufacture them to the VDI standard, which is a German criteria, which is in some instances harder to achieve. But if you do achieve it, what you do guarantee is that you've got a machine that is certainly more than fit for purpose. And one of the areas with the Takumi range as well, which is really impressive, is the fact that they don't use the software to, if there's slight inaccuracies in axes, they don't use software to compensate for that. It's all done in the hardware, it's all done in the geometrics. The machine is built and scraped in order to give you precision results and great surface finishes on parts like you can see here. But of course, that design is what goes into it.
Paul, it's been fascinating, absolutely fantastic technical corner, a brilliant technical corner and review on the Takumi H Series from Leader CNC Technologies.